Hi guys, here I am with another topic, basically modeling part. So in this, we have to first know a few terms and terminologies, and after knowing that, then we can go with the modeling part. So this part will be divided into two parts. Okay, let's discuss now. As usual, I'm importing some packages here like OS, Pickle, Pandas, NumPy, and sklearn packages for the modeling purpose. Okay, so as usual, first we need to read the data. This is the path where the data files are stored, and directly I will be reading the featureized data sets. Okay, so this is my featureized training data, featureized test data, and then I'm also reading the original train data, but I think I haven't used it, but let's just keep it. Okay, now in our train data, we must remove the category column. It's a target variable. So like we will be removing ID as well, and we will be taking the category names from the original train data. Okay. The shape of the files are data sets are as follows: the training featureized shape and the test featureized shape. So we removed ID from the test. Again, we can get it back. It's not a problem. So in the train data, we have category still. So now after checking everything, if it is correct, we must split our data set. So as usual, we will be taking the stratification technique, applying that technique. Uh, Data equals train SFDF. Remove the category column because it's a target variable, and take the Y separately. Y is nothing but the target variable, and X is nothing but the features, which features which we obtain by removing the category target column. We also do pre-processing technique, basically standard scalar, nothing but the column standardization. We subtract mean of the column with each point and divide by the standard deviation of the column. So that simple technique we apply. It's nothing but a pre-processing technique. And this is the function that it does. And later on, we normalize the features by calling this function here by passing our x as our input. And then we split our data: x train, y train, x test, y test. So for splitting, we'll be using the train test split function from sklearn, wherein we pass our x norm as the input and y as the target. Since we want to do stratification split, we specify stratify argument with y as our value for the stratification sampling. Test size is 0.20, nothing but the 20% of the whole data set that is taken for test. Okay, y train and x test and y test. So after that, we also need validation set. This is something we take it to check the performance of the model. So again, we take x train, x valid, y train, and y valid. Here, we'll use the same function called train test split, but with x train as our input and y train as our target input. Stratify equals y train, test size is 0.20. So we also need 20% for validation from the original train data. Now, when we check the sizes of the target columns for all the three sets, it is equal. That means it's good to go. I mean, we can proceed with our further process, and there is no missing points here. sometimes what happens is that we might have more classes in train and less classes in test. That should not be there. And the shapes of the training sets, all the three sets, training, validation, and test sets, are as follows: 5,61,000 for training, 1,40,000 for validation, 1,75,000 for test data. This is simple splitting and pre-processing part. And the next thing is we take the labels, nothing but the class names, separately in the form of a list. So these are the classes we have: arson, assault, bad checks, bribery. All these are crimes, unique crimes that have been recorded. And now we have some helper functions to plot our metrics. So we have three metrics: confusion matrix, precision, and recall. So these are basically our heat maps. So this function is just for plotting the heat map. The inputs are matrix, title, labels, and CMAP. So it just plots by taking these inputs, it plots the confusion. It plots the heat map of it for whatever matrix we pass. This function is being used in the following function. So I'm using Seaborn to plot the heat map. I set the figure size first and then plot the heat map by passing my matrix. And these are the inputs of this function. And later on, I set the layout, class label, X label, Y label, title, and later I show the plot. This is simple helper function. And in this function, in the following function, we actually track the metrics. So confusion matrix is a function that is taken from sklearn library. Confusion matrix just shows a summary of our predictions with respect to our true target values. And let me show you the confusion matrix image. This is the confusion matrix structure. We have the predicted values and the actual values. And of course, this is used for binary class, but we can extend this for multi-class also, multi-class classification. So this is a ground truth, and these are the predictions that we get. True positive. That means how many points are exactly matching with the actual ground truth and the predictions that we get. So if the points are equal, then we say it is a true positive. That means the model was successful to predict the point which is equivalent to the actual ground truth. Similarly, we have something called true negative. So in binary class, we have positives and negatives, right? So this value is nothing but the ratio, not the ratio, but the count of all those points which the model predicted to be true negative, and those points are actually matching with the ground truth also. And the next thing we have is false positive. This is the count where the model predicted the points as positive, but they are not positive. It's been misclassified as positive, but it belongs to negative class. That's why we have false positives, falsely identified as positive points. Similarly, we have something called false negative. This is quite opposite to the false positive. Here, the model falsely predicted the point as negative, but it belongs to positive class. That's the difference. I know it can be tricky initially, but that's how we read. And similarly, we have the same matrix for multi-class, that is more than 2 classes. This is how we read. This is something, of course, this can be read and understood. And what is precision and what is recall? Let me show you another image for that. Yeah. So in confusion matrix, we have TP, FP, FN, and TN. Right? Let's say this is how we get. If we visualize, this is how we get. Okay. True positives are these points which are inside this circle and left side, and false positives are these points which are the right side, which are in the right side and inside the circle. Now, what is recall? Recall is nothing but the ratio of true positive by the points which have been retrieved. The ratio of Fn plus Tp. We can also say it as how well the model actually recalled the points to be positive. Recall, that's how we take. How well the model actually predicted it to be positive point. And in the precision part is the ratio of Tp by Tp plus Ft. How precisely the model predicted these points to be positive. And from the whole positive category, true positive and false positive, we keep it in denominator, and TP is the model that it predicted to be positive point. This is how a recall and precision have been calculated. And coming to accuracy part, in accuracy metric, we make sure we add all this Fn, Tp, Fp, and Tn in the denominator. And in accuracy, we mainly take the true points, true positive and true negative. We neglect false positive and false negative. These are the points which the model misclassified. So we do not consider this, but we consider only TP and Tn. So visually, this is how it is seen, and please read about it in the online platforms, online blogs, online videos. You will get good clarity in this concept. Now coming to our part. So here, this is the confusion matrix code. It takes Y true and Y pred, true classes and the prediction classes, and it calculates the confusion matrix. And then we calculate the precision and the recall. Now, these three are the matrices. We must visualize it in the form of a heat map. So we use the above function in this main function by passing our matrices, sorry. And we give the title and then the labels as usual, simple stuff. So I hope you got till now. In this, we just discussed the splitting part, pre-processing part, and the confusion matrix and precision metrics. So confusion, precision, and recall performance metrics, right? We just discussed that. Now in the next video, we will actually discuss the results of the models and the summary part. I hope you got my point.